What happens if you fire a gun in space? Space is a vacuum. There's no air. So what would happen if you fired a gun in space? Many people assume the gun wouldn't fire at all. After all, without oxygen, gunpowder shouldn't burn, right? Surprisingly, that's not true. A gun will fire perfectly normally in space. So how is that possible? Let's follow the entire process, from the moment the trigger is pulled to what happens after the bullet leaves the barrel. A modern cartridge consists of four main parts: the bullet, the cartridge case, the primer, and the propellant. When you pull the trigger, the firing pin strikes the primer. The primer creates a small explosion, producing a hot spark that ignites the propellant. Here's where many people have a misconception. They think gunpowder burns the same way wood burns, by using oxygen from the surrounding air. But modern ammunition uses smokeless powder, and it works very differently. Its primary ingredient is nitrocellulose. Unlike ordinary fuel, nitrocellulose already contains oxygen within its own molecular structure. In other words, the fuel and the oxidizer are built into the same molecule. That means it doesn't need oxygen from the atmosphere to burn. As the propellant rapidly burns and decomposes, it instantly produces extremely hot gases such as nitrogen, carbon dioxide, water vapor, carbon monoxide, and hydrogen. These gases expand under enormous pressure, pushing the bullet down the barrel. And that's exactly why a gun can fire even in the vacuum of space. So what happens after the bullet leaves the barrel? Let's start with its speed. On Earth, air resistance constantly slows a bullet down. But in space, there is no air. That means there is essentially no aerodynamic drag. The bullet continues traveling at almost exactly its original speed. Of course, it won't fly forever in a perfectly straight line. The gravity of Earth, the Moon, the Sun, and other celestial bodies will eventually alter its path. But unlike on Earth, it experiences almost no loss of speed due to air resistance. What about the sound? In space, you wouldn't hear the gunshot. Sound requires a medium, such as air or water, to travel. Since space is almost a perfect vacuum, there is no medium to carry the sound. The shooter would still feel the recoil and vibration through the firearm and spacesuit. But no one nearby would hear the shot. What about the muzzle flash? Would it disappear as well? On Earth, firing a gun produces a bright flash at the muzzle. Many people assume this is simply burning gunpowder. In reality, it's more complicated. The extremely hot gases leaving the barrel still contain gases such as carbon monoxide and hydrogen that can undergo further oxidation. When these extremely hot gases mix with oxygen in the atmosphere, they continue reacting in a process known as afterburning. This additional reaction is responsible for much of the large muzzle flash we see. But in space, there is no oxygen. So this afterburning does not occur. Without oxygen, the familiar muzzle flash would disappear. Any visible light would come only from the extremely hot gases themselves, not from a burning fireball. Then what about the flash suppressor? A flash suppressor works by dispersing the extremely hot gases into multiple directions. As the gases expand more rapidly and cool down, afterburning is reduced, making the muzzle flash much smaller. But in space, afterburning barely occurs in the first place. As a result, the flash suppressor is not needed. Now let's talk about recoil. According to Newton's third law, every action has an equal and opposite reaction. As the bullet moves forward, the gun moves backward. If an astronaut fired a gun while floating freely during a spacewalk, they would slowly drift in the opposite direction. However, if both the shooter and the firearm were securely attached to a spacecraft or another structure, the recoil would simply be transferred to the spacecraft. Since the spacecraft has an enormous mass, its movement would be almost impossible to notice. So far, it almost sounds like guns work even better in space. There is no air resistance, no audible gunshot, and much less muzzle flash. So is there any real downside? Actually, yes. And it's probably not what you expect. The biggest challenge is heat. The gases produced by burning propellant can reach temperatures of around 2,500 to 3,500 degrees Celsius. So why doesn't the barrel melt? Because those extreme temperatures belong to the gases, not the barrel itself. The hot gases remain inside the barrel for only a few hundred microseconds. The barrel absorbs only a portion of that heat. The real problem comes afterward. That heat has to go somewhere. On Earth, the barrel continuously cools by transferring heat to the surrounding air. But space has no air. The most effective cooling method, convection, is no longer available. The barrel can lose heat only through thermal radiation and conduction into the rest of the firearm. As a result, once the barrel becomes hot, it cools much more slowly than it would on Earth. Firing only a few rounds isn't a problem. But during sustained fire, heat continues to build up. Eventually, excessive barrel and chamber temperatures can lead to overheating. And in extreme cases, even cause ammunition to ignite unintentionally, a dangerous phenomenon known as cook-off. So let's summarize. A gun fires normally in space. The bullet maintains almost all of its speed because there is virtually no air resistance. Gunshots cannot be heard. Large muzzle flashes are greatly reduced. Flash suppressors become much less important. Recoil still exists, but if the shooter is securely attached to a spacecraft, it isn't a major problem. The biggest challenge isn't firing the gun. It's cooling it. Without air, the barrel cannot shed heat efficiently, allowing heat to accumulate during sustained firing. Many people believe the biggest obstacle to firing a gun in space is the lack of oxygen. In reality, the greatest challenge is getting rid of the heat. Thank you for watching, and see you at next video.